Hey subs, I'm Sayantan. Anything weird at mathematics? Let's math magic. So today in this chapter we're gonna discuss about the numericals of the chapter lengths in physics. So before we get started, we will just know few terms and terminologies regarding this chapter. So let's get started. So before starting the numericals, we will first know few parts of the lenses. Like there are actually two types of lens. One is here convex lens and another one is here concave lens. So in these two types of lens, few parts are there. Like two focuses are there. That is, one is first focus, another one is second focus. And one point inside that lens, that is called the optical center. And this line, which is a horizontal line, you can see that line is called the principal axis. So before starting the numericals, the very important things like this small f denotes the focal length. So what is the focal length? Like from O to F1, the distance from the optical center to the first focus or second focus is called the focal length of the lens. And this small u is called the distance of the object from the lens. Like here, the one object we can see over here, like AB, and this is the image after refraction from the lens, that is A dash B dash. So here the value of u will be the length of OA, and then we come to small v. This small v is the distance of the lens and the image. So here the image is at A dash. So v equals to, it will be, for this diagram, it will be O A dash. Next on small m. Small m is the magnification of one lens. I'll come to this part later on. Next is capital I. Capital I denotes the size of the image. Like here in this figure 1, the image is at A dash B dash. So A dash B dash will be the size of the image. O means the object. So here the object is AB. So size of AB will be the value of O over here. But for solving the numericals, we have to keep some sign convention in our mind. Let us come to that part. So for sign convention, we just will remember the coordinate geometry. As like in coordinate geometry, as we know, in the x-axis and y-axis, if we go to the right side, it will be a positive sign. If we go up, it will be also a positive sign. If we go left, it will be a negative sign regarding the x-coordinate. And if we go to the downwards, it will be a negative value of a y-coordinate. So same like that, if we talk about lens, suppose I'm drawing a basic diagram. Object is here and two ray we will consider while we will drawing a diagram. That one ray is parallel to the principal axis, and after converging it will pass through F2, and another one ray we will consider through the optical center, that is passing through O. So while passing through O, as we know that any rays pass through the optical center of any lens, that rays goes undeviated, means there is no deviation of the ray. So there will be no change in direction. So wherever that two rays are intersecting to each other, like in this point we will get one image of that object. So here, if we ask you that what is the sign of u over here, then you can easily recognize that this O and this u is actually at the left side. So u will be here negative. And if I ask you what is the sign of v over here, small v, that means the distance of the lens and the image, that will be obviously positive, because we will just judge this lens as the y-axis and the principal axis as the x-axis. And just remembering, keep that the coordinate geometry in your mind, you can easily recognize that the sign of the f there are small u, small v, I and O. Like here you can see the object here is just upright, means above the x-axis. So this value of I will be surely a positive value. But here you see, sorry, this will be the object. But here you see our image. Our image is just below the x-axis, so we have to go downwards. So this value of I must be a negative value. So in this way, we have to determine the value of u, the value of v, f, I and O, all are negative or positive. Now just before solving the numericals, there are just two formulas are there for solving the numerical sums. First one is called the length formula, that is 1 by f equals to 1 by v minus 1 by u. And the next one is small m equals to I by O equals to v by u. Here I have already told you that this capital I denotes the size of the image, this O denotes the size of the object, this small v denotes the distance of the image and the lens, and this u denotes the distance of the object and the lens. So here we will consider one special case. If the object is placed in between the fast focus and the lens, then the image formed here, that is virtual type, because we will consider two types of rays. One is parallel to the principal axis and another one is from the optical center. But we will see that on another side the two rays are not meeting to each other. So that's why we have to draw some backward lines. Then on the same side where the object lies, the image is forming, that is A dash B dash. So these types of image is called the virtual types of image. But here in any types of image, we will consider three properties of the image. First one, is it virtual or real? Second one, it is upright or inverted, means it is erect or inverted. And the third one is it is magnified or diminished. Like here in this diagram, we can see that the object here is smaller than the image. So here we will see that the image has been magnified. And you can see over here like the image formed here, that is erect, and also it is a virtual types of image, because you just remember one thing, if the object and the image both are forms in the same side of the lens, then the image will be always a virtual types of image, because it cannot be captured in a screen. So here let us consider the 6 things. Like, can you tell me here what will be the sign of u? Obviously you can tell, because that object here is situated at the left side of the lens. That's why the sign of u will be obviously negative over here. But what will be the sign of v over here? You can see easily that the image is here, and which one is the left side of the lens. So as I have told you that lens you consider as the y-axis, so as it is at the left side, so this value, that means the v, will carry the negative sign. And here you can see the object and the image both are upright and both are above the x-axis, or here what we say, that is principal axis. So as I told you, both of them will be positive sign, as well as your object and your image both will be carrying the positive sign. So first problem in this video, that says a lens formed the image of an object placed at distance 5 cm from it at a distance of 60 cm in front of it. Find the focal length and the magnification and the nature of the image. So whenever they will ask you for the nature of the image, you have to tell that 3 properties of the particular image formed. So here you have to know whatever the data are given and whatever the data are asked. Like here in the first line I can read that they have told the object is placed at a distance 15 cm from it. So this 15 cm must be the value of u. So can you say? See, for both the lenses, the object is always at the left side, we consider. So here this e will be a negative value. Here also one more thing told, that the image of the object is forming 60 centimeter in front of it. So the value of V is here 60 centimeter and V is also in front of the lens. So V will be also at the left side. Like if I draw you one basic diagram for this. So to solve the sum, we will use here the lens formula, that is 1 by f equals to 1 by v minus 1 by u. So here we will put both the values, that is the value of v obviously with sign and the value of u. So if we calculate over here, we will get something like this, and the LCM of 50 and 60 will give us the LCM 60. So here I am getting 3 by 60, that is after cancellation 1 by 20. So if we reciprocal both the sides, we will get the value of f equals to 20. Means the value of f here it is coming positive, and obviously it is true because what we can see, the parallel ray what was parallel to the principal axis, that is meeting on the principal axis at this point, that is denoted by here f2. So here obviously the focal length is at the right side, so the value of f must be a positive value. So we got the first answer. So in the next question they have asked what is magnification. So in magnification we got two formulas. One was m equals to I by O equals to V by U. So here as we don't know the value of I and O, with the help of the value of V and U, we will find out the value of m. Like here from this equation we will make one equation like this. So here if we put the value of u and v, we will get something like this. The value of m what we got, that is 4. And if you just look at the diagram, you can easily answer the question number 3, that is what is the nature of the image. The nature of the image will be obviously a virtual image, and the image is here erect and the image is here magnified. So we got the answer of the question. So till now majorly we have discussed about the convex lens. So let us consider one concave lens over here. So here I have drawn one basic diagram how an image formed from an object. So here you can see our object is at AB and one image formed of that object, that is A dash B dash. As I have told you, whenever we will draw a image of lens chapter, we will always consider two types of ray. One is the parallel to the principal axis and another one will pass to the optical center. And as we know, the concave lens is called the diverging lens also. That's why that ray which is parallel to the principal axis, that ray will diverge to the upper side. And as we know, for both the lenses, if one ray is coming and passing through the optical center, that ray will go undeviated. So that's why this ray is coming and going straight away. But as you can see, at the right side of the lenses, two rays are coming and they are like, they will not meet with each other and all the time, because you can see the gap between the ray is increasing as we can go furthermore. So these two rays will not intersect to each other anymore. So that's why to form an image, we have to consider two backward rays. That two rays are meeting at this point and is giving us a image. Here the image is at A dash B dash. So here can you tell me the three nature of the image? Obviously you can see here that the image A dash B dash is an upright image because it is situating above the x-axis, or whatever you can say, it is the principal axis of the lens. So it is an erect image. And you can see over here that your size of your object and the size of your image has been decreased. That's why it is diminished. And the last one and the final one, this is a virtual type of image because both the image and the object both are situated at the same side of the lens. So now let us consider one more thing, that in the last sum we had a value of u and v both were negative. So how could we determine that it was a convex lens, not a concave? Because here you can see that u will be obviously this part and your v will be only this part. So if you go to the previous sum, you will obviously notice that the value of u was 15 centimeter and the value of v was 60 centimeter. That means the image was formed far behind the object. So that's why we can consider it, and we are definitely sure about that was a convex types of lens, not a concave one. So hope you have understood the numericals of the lens chapter properly. If there is any further more doubt, please let me know in the comment section below. And don't forget to subscribe to our channel. Thank you. Have a nice day.